Hello everyone, this is Mohamed ElShrif from QCRI. I'm very happy to demo our QARTA framework, which is an machine learning based system for accurate map services. You can consider it as an alternative to commercial maps such as Google and Here Maps. QARTA was tested on real life settings and it shows its superiority in terms of accuracy for time estimation. QARTA is also unique in terms of street-aware settings where we are able to learn different traffic models for different paths of fleets with cars and motorcycles. Finally, QARTA is deployed in production for several local companies in Qatar, including the national taxi company Karwa and the third largest food delivery company Rafiq, that issue more than 2 million requests per week. This is the general architecture of QARTA, and as you can see, it is a multi-layer architecture that is responsible for creating accurate topology maps and edge weights for individual road segments. So the first layer is called data layer, which has many tasks including collecting data from different sources, indexing, and cleaning different spatial and temporal types of data. The second layer is called map making layer, and it is responsible for improving the map and its topology. In addition, this layer is responsible for learning the individual weight of each road segment. The third layer is known as query calibration layer, where it encompasses a couple of machine learning components which are responsible for adapting the results in real time to the user who issued the query. The full details of the QARTA system is accepted in the VLDB this year, so make sure to attend our presentation. We demonstrate QARTA through these panels. The first welcome panel, as you can see here, it allows us to visualize in real life the locations of different cars and motorcycles that belong to Karwa and Rafiq companies, which are currently using our QARTA system. These vehicles send data to QARTA. The data includes the lat long of the vehicle, its speed, direction, and timestamp. In addition, this dashboard tracks the vehicle status, and each color encodes different vehicle status. For example, this green color represents a free vehicle, whereas the red color represents the hired vehicle. And the yellow color represents a dispatched vehicle, which means it is going to a specific location either to pick up a client or it is going to deliver an order. Also, this dashboard shows the number of API requests that have been sent from Karwa and Rafiq to our backend server during the last 24 hours. The second panel, in which the user, for instance, can choose a specific day of the week and pick an hour within that day, and visualize the actual traffic patterns of individual road segment for that particular hour of the week. This is extremely important for the analysis to understand the congestion behavior at different locations of the city and at different times of the day. For example, if we pick up the 8 in the morning, and you can see how the most roads are congested. Also, the user can hover or click on individual road segment to visualize the metadata of that specific road, where a pop-up will appear like in here, with different metadata such as traffic speed and type of the road and so on. The query panel. This panel allows the user to interact with QARTA and issue an actual query, either routing, KNN, or range query. Also, the user has a freedom to use either QARTA map or base map like OSM map. Also has an option to use the calibration. Then the user can choose the pickup location and the destination to get this route. So now we get the instance of this route, the ETA. Also, in addition to that, we get the OSRM ETA, which is a free flow ETA, and the Google ETA for comparison purposes. The final panel is executed by us for running the backend part of the QARTA, which is important for fine-tuning the system. This panel allows us to decide how frequently we want to update our different machine learning models. For instance, if we take the QARTA calibration part, we run it every week. Then, for each run, we use the data from the last month. So we have a sliding window that we used for training. In addition, we have some parameters for the algorithm itself, like the temporal partition and the spatial partition. In the left graph, we visualize the median absolute percentage error for both the QARTA calibration and QARTA map on a specific day at each hour of the day. In the left figure, this bars represents the QARTA accuracy for the last week. Thank you
for your attention.